So division by a certain number can be thought of as multiplication by that particular fraction. Okay, 3 divided by 7, well, that's just 3 times 1 over 7. Okay, 100 divided by 20, that's just 100 times 1 divided by 20. Okay, so any division can be the division done directly, or it can be multiplying by a fraction with a 1 on top. And how you can write that is, for this 3 divided by 7 situation, 3 divided by 7 equals 3 times 1 divided by 7. This is just another way of writing 3. Okay? And you can multiply and divide this in any order. You can do the 3 times 1 first. 3 times 1 divided by 7, which grants you 3 divided by 7, what we started with. You can do 3 times 1 over 7, which will also grant you the same answer. And you can do 3 over 7 times 1. And of course, anything multiplied by 1 is your very same 3 divided by 7. Okay? So you can multiply and divide in any order as long as you remember that dividing by something is like multiplying by 1 over that something, right? So A divided by B, that just means A times 1 over B. It's another way of writing the exact same thing, okay? We're just not working with whole numbers anymore, okay? We have our whole numbers 1, 2, 3, 4, 5, and so on. But what about something that's less than 1, right? Between 0 on your number line and 1, there could be many, many different numbers. There could be a half. There could be a third. There could be a fourth. There could be a fifth, and so on, right? And you can multiply by these numbers just as the same as you can multiply by whole numbers. And division is just multiplying by one of these numbers, okay? And you can ask, well, what about something like 3/5? Well, that's just 1/5 plus 1/5 plus 1/5, okay? And we again return to everything being addition, right? Because you have 1/5 added up 3 times. 3 times 1/5, by definition of what multiplication is. 3 times 1/5 is 1/5 added up 3 times. Now, if you add up 1/5, you can write that as 3/5. Right? That's what 3/5 is. It's not 1/5, it's 3 of them. Okay? This is what fractions are. Right? People, they think fractions is some different animal of numbers, some different subset of mathematics. Fractions is just division. Right? When we have 3/5, all that means is 3 divided by 5. What does 3 divided by 5 mean? It just means 3 times 1/5. And when you see that division is just multiplying by 1 over some number, you see that division and multiplication is the same thing and therefore can be done in any order. All right? So, to show that this is true for all numbers, A divided by B means 1 over B plus 1 over B plus 1 over B, and so on. how many times? A times, right? That's what A over B means, right? 3 over 5 means 3/5. It means how many fifths do you have? You have 3 of them. But we've seen this notation before. Something added to itself, A times, it's just A times 1 over B. Right? We've seen that notation before. Right? That's all that any division is. A divided by B is just A times 1 over B. So let's say we have something like 4 divided by 2 times 8 times 3 divided by 4 times 2. Okay? Let's say you do all the division first, as BEDMAS would suggest. Division first, then multiplication. Well, you have 4 divided by 2, which is 2, times 8, times 3 divided by 4, which is 0.75, times 2. And then we do this calculation. We have 2 times 8, which is 16, times 0.75, times 2, and we get 24 as our answer. Okay? Following the BEDMAS rules, dividing first. Okay? But let's do everything in order. If we can do multiplication and division in any order, let's do that. Okay? So, 4 divided by 2 times 8 times 3 divided by 4 times 2 equals, well, 4 divided by 2 is 2 times 8 times 3 divided by 4 times 2. Next we have 2 times 8, which is 16 times 3 divided by 4 times 2. Next we have 16 times 3, which we saw before as 48, okay, divided by 4 times 2. Then we have 48 divided by 4, which is 12, times 2. And 12 times 2 gives us the very same 24 that we saw before. 24. So you actually don't have to do division first. Okay? Let's do things in the completely opposite way. 4 divided by 2 times 8 times 3 divided by 4 times 2. Let's do all the multiplication first. And only then will we divide. And you're going to see what happens. Okay? 4 divided by 2 times 8 times 3, which is 48. 4 divided by 48 divided by 4 times 2, which is 8. Okay, well guess what? 4 divided by 48, and then that divided by 8 is 0.0104 and so on. It's a very small number, and it's certainly not equal to 24. So what happened? What happened is we have to remember that when we put this bracket here, we're misrepresenting that 2. When we're dividing by 2, we're actually multiplying by 1 over 2. And by placing this bracket here, separating the division from the 2 and connecting the 2 to the 8 and the 3, which are different numbers, we're creating a different question. When we put this bracket here in front of the 4, separating the 4 from the division sign, we're breaking what was written before, which is we're actually multiplying by 1 over 4. Not multiplying by by 1 over 4 times 2, or 1 over 8, which is what's going on here. So if we record our division in a way that clearly communicates that dividing by a number means multiplying by 1 over that number, then we don't run into these issues. Okay? 4 divided by 2, well, we're actually multiplying by 1 over 2. Times 8 times 3 divided by 4, that's just multiplying by 1 over 4. That's what's going on there. Times 2. This is what the above expression really means. It's just another way of writing it. The division sign even looks like one number over another. So let's skip the middleman and just write it that way. Dividing by 2 is 1 over 2. Dividing by 4 is 1 over 4. And now we can do things in any order we want. Okay? And if you want to do that multiplication first, let's do that. Let's put in brackets here. And let's put in brackets here. Notice that this is the same place where we had brackets before. But we're actually writing things properly. We're actually writing the numbers as the way they're supposed to be written. Dividing by 2 is multiplying by 1 over 2. Dividing by 4 is multiplying by 1 over 4. And let's see what we get now. 4 times 1/2 times 8 times 3 is 12. Times 1/4 times 2 is 0.5. 4 times 12 is 48, times 0.5 is 24. The same number. So, when you keep in mind what division actually is, it's 1 divided by the number and multiply by that, right? A divided by B, or A divided by B, that just means A times 1 over B. Then you can do proper division and multiplication in any order you want, because division is just multiplication. And that's why I encourage students to avoid using this symbol, because it's misleading. Okay? When you use this symbol, it looks like you're working with a whole 2 and you're dividing by it. But it's much more clear to think of it as multiplying by 1 over 2. And mathematicians, physicists, engineers, people who work with numbers regularly, they actually use this notation much more comfortably than this notation. Okay? So this notation is more straightforward. And especially once you get into more fraction operations, you see that once you think of fraction as just being division, okay, 3 over 5, it's just 3 divided by 5, then that becomes much more simple. But fractions is something that we'll deal with another day. So, in BEDMAS, if you understand that subtraction is just adding negative numbers, right? A minus B is just A plus negative B. If you understand that division is just multiplying by 1 over the number that you're dividing by, then you understand that you can divide and multiply in any order, and you can add and subtract in any order. But reading BEDMAS is a lot easier than reading BEMDSA. So we call it BEDMAS, right? And that's why brackets are first, by definition. Exponents come after, because exponents are just another way of writing multiplication. Multiplication comes after, along with division, because division is another way of writing multiplication. And addition and subtraction comes after, in any order again, because subtraction, it's a special case of addition. It's adding a negative number. So that's where BEDMAS comes from, and hopefully that will help you do these kind of calculations and avoid the common mistakes we talked about when adding and subtracting a string of numbers or dividing and multiplying a string of numbers.